Hi everyone, my name is Calculus, and if you want to check out on more of my videos, you can visit on YouTube at the Calculus Academy. Okay, you can check out for more of my videos there. Now, in today's class, I'll be talking on relation. Okay, talking on relation. Okay, what is relation? That's the first thing we have to do is understand what relation is. So, what is relation? Now, what relation does is relation shows the relationship between two sets. That is, it shows the relationship between the elements of two sets. All right. Now, what it does is it tells us which element in a set relates to another element of another set. All right. In simple terms, you could say that relation is a set of ordered pairs. All right. So I'll use a very simple diagram. Okay. I'll use a very simple illustration to show you or explain the definitions properly. Now let's assume that we have the set X. Okay. Now in the set S we have an element A. Right. We have another set Y, and in the set Y we have another element B. Okay. So what relation does is that it shows us the relationship between the element of set X. Okay, this is the first set, and the element of set Y, which is the second set. Okay, so if I wanted to say A relates to B, I would just use an arrow to move from the first set to the second set. Okay, this arrow shows here that A relates to B. Now, it means I could say that the possible relation here is given by the set of ordered pairs AB. It's as easy as this. But that A, remember that A is an element of set X, which is the first set. And also remember that B is also an element of set Y. Okay? So this is what relation is all about. Now, there are some terms that you have to understand. Okay? The terms like domains, codomain, and range of a relation. Okay? Now, this first set that relates with the second set is normally called the domain. Okay, so I could call set X, I could call set X the domain. Okay, it's the first set actually. So elements of the first set that relates to the second set, they are called what now? The domain. They are the first elements. Okay, so when you have a set of pairs, when you have a pairs like this, let's say one, two, the first one here actually stands for your domain. Now, Y, the set of all possible values for Y is called your codomain. Okay, the set of all Y is your codomain. What it means is that what it means is that I could say, for instance, let me give you an illustration. For instance, I could say that in set X, let's say in set X, I have John. Okay, I have John. I have Mary, for instance, and John and Mary relates to another set in Y, and the sets in Y are different fruits. Fruits like your orange, your mango, okay. Then you can also, let's say it relates to these two fruits here. You can have other fruits, okay. You can have other fruit like, for instance, your pawpaw, okay. So what it means here is the set of John and Mary that relates with different fruits in the other sets. These are called the domain, all right. Then the set of the different fruits that John and Mary wants to relate to, the set of all the fruits that John and Mary wants to relate to, is called the codomain. Right? It's called the codomain. Now, so at this point in time, I know that set X is domain, set Y is codomain. But there is another term that I want you to take note of. Range. What is the range? What do we call the range of a relation? Listen. Now, you see this element here that element A relates to. These B, they are called images. Okay, or you can call B the image of A. Okay, so B, you can call B the image of A. So the set of all the images from this set, all the image that the element of this set forms, okay, they are called the range. So it means that if, for instance, let's assume for instance here, John, let's say for instance here, John relates, or John is related to orange, okay, and Mary is related to mango. And let's say for instance, the pawpaw here has no relationship. It is very possible. So now it means that the set of orange, mango, and pawpaw under the Y, they are all called the codomain. But however, what are the images of John and Mary? The image of John is orange. The image of Mary is mango. What it means is that the range, the range here, the range here are going to be orange and mango. While the domain will have John and Mary. From this simple illustration here, what you can deduce is that the range is a subset of the codomain, which means that the range is inside the codomain. All right. So I could conclude. I could say this. You can pause the video and just take this down. Okay. I could say from what I've just illustrated here, I could say, or I could conclude that the range is actually a subset. And you know this is symbol for subset. Okay. Is actually a subset of your codomain. Okay. What we have here is a question that tells us to list the domains and range of the relations. Okay. Right, we said already that relation is the set of ordered pairs. Okay, so this set of ordered pairs here, they are said to be relations. Okay, there are two different relations on the board. And remember, I told you also that when you have a relation, the first elements that you have, they are called the domain. Okay, so it means I can say this that the domain for the first relation. Okay, the domain for the first relation would be, we have 2 minus 3 and 0. 2 minus 3 and 0 is the domain for the first relation. Then what is the range for the first relation? The range for the first relation here should be 1, 4, and 5. Okay. Now 1, 4, and 5. Now if you check this the first relation, you would see that there is a specific image for every input. That is, for every domain, for every element of a domain that you have here, it has a specific image. That is to say, that the one element to one, one element on the outputs, okay, then okay, one element on the inputs, one element on the output, okay. So it means that if I wanted to draw a mapping for this guy here, I would say that what we have here, this is 2 minus 3 and 0. Then this is the domain. Then for the other side, you can have 1, 4, and 5. So what we have here is simple, okay? Now, 2 relates with 1, so 2 relates with 1. Minus 3 relates with 4. Then 0 relates with 5, so 0 relates with 5. Now, you can see that every image, every of the inputs here, okay, has only one image, right? So remember I told you that once we have this case, then you can say that the relation is a function, okay, is a function, alright? Now let's check for the second relation, which is this other relation here. The domain for the first one would be 1 minus 2, 1 minus 2, 3, okay. However, you can see that we're already having a minus 2 again here. So there's no need to write that one, okay? We're already having a minus 2. So what we have is 1 minus 2 and 3. Because we already have minus 2 before, so we can have minus 2 again here. Now, the range for this is the domain for the second relation. The range for the second relation would be 3, 4, 3, 4, minus 2, 3, 4, minus 2, and 7. Right? Now, if I wanted to create a mapping, okay, for this relation here, I will do this. For this guy, okay, for the domain, we have 1 minus 2 and 3, okay, while for the other set, we have 3, 4, minus 2, and 7, right? Now, 1 relates with 3, 1 relates with 3, minus 2 relates with 4, then 3 relates with minus 2, again, minus 2 relates with 7, so minus 2 relates with 7. So I can see clearly from the mapping diagram that the element minus 2 has more than one image. 4 is an image and 7 is also an image. Now remember, once a relation has elements in the domain that has more than one image, such a relation is not a function. Okay? So I've been able to answer this question. I've been able to list out the domains and the range for the relation. And I've also been able to tell you why the first relation is a function and the second relation is not a function. All right. All right. These are the several type of relations that we can have. We can have, as the name implies, many to many relation, one to many relation, many to one relation, and one to one relation. Now, let's go to the first one. As the name implies, many to many means that many elements or several elements in the domain relates to several elements in the codomain. Okay, several elements in the domain relates with several elements in the codomain. So you can see from here that we can see 6 relates with 2, it relates with 3, it relates with 5. Okay, now 7 relates with 2, relates with 3, relates with 5. So several elements here relate to several elements here, and several elements here are associated with several elements here. So we can say that the first example is a many to many type of relation. All right. How about the second one that says one to many? One to many means um, one element in your domain has is related to several elements in the codomain. Okay, so you can see it from here. So the first one here, this guy here is a many to many relation. Then for the second one, you can see that one element in the domain has or is related to several elements in the codomain, which means your 3 relates here to 9, 3 relates to 18, 3 relates to 27. Also, 4 relates to 8, 4 relates to 6. So one element here relates to several elements in the codomain. So we can say such a relation is the one to many relation. All right. Okay, the third one we have here is the many to one relation. That is to say, several elements in the domain, okay, relates with just one element in the codomain. Several elements. You can see here that your 12 relates with 12. Your you can see 12 relates with this, 15 relates with this, 24 relates with 12, 36 relates with 12, 45 relates with 5. So several elements here relates with one element on the codomain. So several elements in your domain relates with several elements in your domain relates with one element in your codomain. So this is the many to one. This is the many to one relation. Okay. Then the last one is the one to one. Okay, one to one simply tells you that one element here relates with one element here. Okay, one to one relation. Okay, one to one relation. So we can call this the one to one relation. So it means whenever you see relations like this, you'll be able to tell if it's many to many, one to many, many to one to one. Okay.